Hello, hello. Well, it seems that my Stream Deck died right when I was just trying to set that up. So I'm gonna need to reboot that probably, but I'll do that after the stream. It does mean a little bit of awkwardness. I guess like Stream Deck just crashed. The computer part just crashed, not the actual like deck itself. That's fun. You can maybe just close the program. But until then, let's figure out the stuff that we need to do. So we have a player. Let's see, can I like open up a terminal directly into here? I don't think I can. I'm gonna go into zombie simulator. Yeah, we have to go into here, but here we can move into editor area. And then don't need a CD. Let's do cargo run. Camel in a hat. Good morning. It has been a while. Thank you. And I got a decent amount of sleep, so that's a good thing. All right, so here we have, I think it's 100 humans, and then we can create a zombie. Now everybody just sort of like randomly moves around, which isn't it isn't super optimal. Well, actually, for the humans, I think that's normal. They're also trying to avoid each other, which is perfect. They can bump into each other, but that's pretty much it. They just sort of like then move around. The zombie, what we have that circle. We want them to basically see everybody in that circle and then move towards whoever they see. That's a human. So I'm thinking that we should write a query. So like that, we're gonna have the system like attraction towards the humans, and I think we actually already started writing that. Zombie attraction. Here we go. So we're gonna get the zombies and humans. Then for each zombie, have it move towards the closest human that it can see. So this is gonna be interesting. Now, when we begin, we have 0 zombies. So we should query for the zombies first, and then that lets us know whether or not we can like quit early from this system, or if we continue on. So let's get a list of all the zombies. And I think we have a component just zombie, yeah. Now we're gonna want their location and their acceleration so we can have them like move towards them. So, and I don't know if I care about their velocity. So I think it's just location. And acceleration. And okay, so that gives us this result. Okay, so then we get all of you. Now, do I need to handle this? I want to say we're gonna have to handle this. Let's find out really quickly. So we can run this. Make sure that zombie attraction is being run. I don't think we need mutable. Okay, so if we run that, wait, no, already have. I'll use this one. Yeah, okay, so component for entity not found. Yeah, so we do have to handle this very similar to the other one because there's a possibility that it doesn't exist. Like that component doesn't yet exist in the world. So we have to match this. Okay, so if we have the okay, this is going to give us our query. And we want to return this. And then we're great. Now, if it's this error, it's specifically going to be an error with component for entity not found, which I think we can use this with like a errors component not found. And then we just want to return an okay at this point. But this won't let us do that because expected struct error port found enum. What did I do for this other one? Visualize. Oh, right. Okay, so we get the error here. We extract the error, which is this report, but then we do one more. Okay. So in this case, if it's this error, we're going to return we have to we attempt to downcast it into the error that we don't care about. So this is going to be the error. We're going to downcast ref. We're going to downcast you into the errors. Oh, come on. You can see it. It's the component not found. Fine. Okay, so we downcast you into that. Oh, so we have to match this. Now we have a sum. Okay, so if you were that error, then I don't actually care what you are. I'm just going to say we're going to return an okay. Like that. However, if you're a none, I want to return this error. Expected a type, found a variant. Oh, okay, so it's just errors like that. So then I think some here with errors component not found. literally anything else is the error. Okay, let's try that. So this lets us run it, which is great. Okay, so we get our zombies query back. If the component is not found, which we're not going to continue on. If for some reason there are no zombies, so it's an empty vector, then we also need to like not move on. So that'd be what? We have a vector here, and we'd have, but these would be empty. So let's handle that then next. So if zombies query of like 0 is empty, then let's just, early return. So that should be fine too. Then what are we gonna do? We now have zombies. We need to now, for each zombie, so let's start looping through the zombies. So this is gonna be, now in this case, let's go through the location, because for each zombie, we need to have their location and, their sight range. We need their sight range. Vision range. Okay, so for, let's see. So I want to do this as like just the index. I don't think it really matters. We'll do index, and I guess like wrapped zombie location. Okay, so in zombies query of 0, so that actually needs to be 1. Dot iter, and then we need to enumerate it too. Then that works. We're not gonna unwrap it like that. That's not what I mean by wrapped. We're gonna have to borrow it next. So then it becomes a borrowed zombie location, and then we'll have to downcast it. So let's let, it's gonna be a borrowed zombie location. Okay, it's gonna be wrapped zombie location dot borrow. That's correct. All right, so now we have this ref dine any. We're also gonna need our vision range. So no, not that. This is gonna be our zombies query of position, so 0, 1, 2, 3. Then I'm just gonna borrow it. And not use that borrow. Oh, 3 and then index. Forgot. And okay, no, we have a ref dine any for that. So we have the vision range of this zombie. We have the location of the zombie. I think that should be good enough right this second. Because the next thing is now we need to have all of the other humans. We need to query all the humans. And that should be easy because we have that marker on it. We should just be able to query for them and not worry that we're going to get any zombies mixed in with the humans. Okay, so let's up here also do a query for humans. So humans query is going to be equal to world.query with component. In this case, all we need to do is get their locations. So with location, and that's it. Okay, so that gives us our humans query. We can, I mean, I think we can even go like just first unwrap. And that should, okay, that gives us our reference to all of these humans. Okay, so what do we need to do then? Like, we need to, for each of these zombies, we need to find the distance between them and the human. So that's like that's first. That's the first thing, is like the distance between these two. So now we have our location here, which is ref dynamic, so we need to downcast that too. So let's just do that here. So that zombie location is gonna be equal to the borrowed zombie location. We're gonna downcast ref because we don't need to own it. And you're gonna become a location. Okay, so that gives us that. I'll come back for the vision range in a second. Oh, might as well just do it now. So that the zombie vision range is the borrowed zombie vision range. Yeah, okay. Seems about right. Okay, so now we need the humans, like we need to loop through the humans and get their location. So for now, I don't know if I need the index like this. So I don't think I do. So because it's close. But for this is gonna be just a wrapped human location in humans query. This should be, I've actually already got this. So humans query. Actually, we should probably just call these the wrapped humans. Human locations. So then in here, we can now, for each human location. So for okay, in wrapped human locations, I don't need it. I keep on, don't need to do that. It's in human locations. Okay, so that gives us that. I want to borrow it. So borrowed human location is wrap. Okay, seems about right. And then we need to downcast it. So human location is downcast ref. Okay, that looks about right. So now we have this location. So we have the zombie location, we have our location, and we also have our vision range. So what I need to do is get the distance between two vectors. And I believe that's a subtraction. So you take one vector, subtract another vector, and then get the magnitude of that. And I don't think we have that set up for ourselves. We have, oh no, we do have distance. Never mind. We have distance right there. So let's, okay, so if this is gonna be, we can do, zombie location dot distance, and then we have the other human location. Well, we just have human location is less than, I don't have exactly that. That would be nice though. We could probably do something like that. Because we have the zombie vision range. Right now I think, let's see. Vision range. Yeah, I don't have anything like this, but we can impulse something on it. So vision range. New, here is the, no, I don't want to create a new one. What I want to do is I want to create something to like get it out. So maybe we'll just do like a get. We'll do a hub function get, which takes in a reference to self, returns an F32. Okay. Then I don't need to do a deref from self. I can just do self.0, and I think it auto derefs at that point. And then we'll close you. Yeah, okay. So now we should do a get on this. So human, what was it, like a human location? Keeps on wanting to do like too many closing parentheses. Okay, if that is less than the zombie vision range dot get, oh, okay. So we could just have it be like, I see a human. Perhaps because like this is one zombie, right? Perhaps something that could be interesting here is, what if I do like let mute like human count? We're gonna start this at 0, and I just want to increment this here. And then at the end here, we're just gonna debug our human count. All right, you're unhappy. Oh, you're gonna be unhappy because temporary value dropped while borrowed. Oh, so I can't actually do this where I get like first and unwrap. That's So we have to do this to get, so this is going to be the human query. And then maybe right after it, we can then do that. So let, what is it? Wrapped human locations is going to be equal to human query that first unwrap. That seems to like it. Okay, so let's try running this. See if we can print out like at least something that looks appropriate. So 2, 3, 3, 2. Okay, that's looking about right. It sees that many humans. Okay, I like it. I think it's working. Now, something we haven't figured out. How do I want the zombie to act? Do I want it to choose like the first human that it sees, or the actual like closest human within that range, or just all of the humans within that range? Perhaps it's just like a little bit attracted to every human that it can see. If the humans were smart, they can juke them by like having like a human on each side of the zombie. That could actually be interesting and like lead to like an interesting sort of like stupid zombie sort of like just stumbling around towards like whoever it like whatever groups it sees. But we don't need you anymore. I kind of like that. Okay, so we see we now know this wrapped human location. So what we want to do is take our location minus their location, normalize it, and then it's going to be applied. Okay, so then we're basically going to start creating a force. So let like move force we can create this as like just an empty vector 2. Make this mutable. And so now we're going to create a new force and add it to that one. And then we'll take this entire thing and add it to the zombies acceleration. It doesn't really matter, I suppose, because we can have like the add happen like just to the acceleration itself. So I think what this would be, we're gonna take our zombie minus the human, the locations. So this will be zombie location which is this location. So then I probably want to do like a dereferenced zombie location minus the dereferenced human location. And we're going to assign this to so like I guess it's going to be the new force, right? So force equals do you need to be like double dereferenced? It's something, oh, it's something like this. Yeah. you know, we can probably make this a little bit easier with that get pattern here too. I mean, that's not, I mean, I think I could just do self. But by doing this, I should be able to just do human location dot get. I should be able to do a zombie location get mute here too. Oh, yeah, okay. So this is not gonna necessarily work. I don't want to take ownership of it. So I'll just do the double dereference here. And then subtract that. That'll be fine. So that gives me a new force. I then want to normalize this force. Okay. So we're gonna do force dot normalize. And then we want to scale this up by the zombie speed, which speed is a component. Yeah, speed is a component. So borrowed zombie speed is equals to zombies query. It wants to do a 4. Caleb Dev, hello, good morning. I'm doing good today. Thank you for asking. How are you all doing? Let's see, zombies query a 4, so 0, 1, 2, 3, 4. That is correct. Of index, and then we borrow. Yes. So we do that. Then we have to downcast you. So let zombie speed equals the borrowed zombie speed downcast ref. And then you are going to be a speed. All right, so that gives us that. So we've normalized the force, and now I want to get that so I can multiply it. So I can basically do force times equals zombie speed. I guess like in this case, it would have to be like a clone, right? Like handle multiplication. Oh no, I can just do get that. Oh, because speed doesn't have that. Oh, the speed is just an F32, so I think I actually can do clone. I think that'll work. Mismatch types expected F32, found struct speed. Oh, okay, hold on. Zombie speed. You're this speed. Oh, I was really hoping I could do that. That's like a double deref, I think. Setting up your desktop PC with Arch Linux. Setting everything up on it at the moment. You're using it to watch the stream. Well, I'm glad you're getting that all set up again. Like computer setups are kind of like fun. The like getting back into it, like going through all the configurations. I remember those days when I did that all the time. Okay, so oh, wait, okay, no more errors. We're fine. Okay, that scales that up. Don't need you. So this then scales it up. And then we want to apply this force to our acceleration. So we have our acceleration here. Now we have location, range, speed. We need our acceleration. So so this is gonna be let mute borrowed zombie acceleration. It's gonna be equal to zombies query UR0122. And then we have the index. And then we're going to borrow mute. Okay, that gives us that, and now let's downcast this. This is going to be the zombie acceleration is, and not exactly. Oh, wait, this is just going to be the zombie acceleration. Equal to the borrowed zombie acceleration. We're going to downcast mute. And you're going to be an acceleration. And we're going to unwrap you. Okay, so that gives us mutable zombie acceleration that we can use. Selective duplicate. Hello. Oh, the power is out for you. Oh no, that's not good. Hopefully everything is okay. Things are working well so far. We've got the zombies are moving around. We're able to visualize that zombie, and now we're making it so that they're attracted to all the humans that they can see. And we're gonna see how OP or underpowered that is. Okay, so we just got our zombie acceleration. So now I want to take this force and add it to the zombie acceleration. So we're gonna do zombie acceleration plus equals to this force. Now you are the wrong thing, so you need to be like double dereferenced. Love and death. Yes. Okay, that seems to work. The other thing is zombies are moving randomly. So here, I don't need this move force, turns out. We're just creating that move force here and just adding it in for each one. Okay, that's great. We need to come back into the randomly walk here. We need to make sure, well, we are doing it for human. What was causing the zombies to walk randomly? It's not this. that's just doing velocity and location. We reset that. Randomly walk is for humans. I think we're fine. I'm a little bit concerned. Okay, so first of all, I want to come back to here. I want to actually turn this off just for a second. Because I want to verify that like we're not moving. But I think our zombies move. Yeah, our zombies are moving on their own, and I need them not to do that. So we need to figure out why that is. So first of all, zombies. When we add a zombie, you get component zombie. You do not get component human. So that's fine. Okay, systems. Containing this in there. This is not touching your like anything else. Okay, so draw entities shouldn't be touched like doing that. Human repulsion. Oh, look at this. It's being repulsed by other humans. We need to make sure that we're doing this with component human. Only humans are being repulsed. Let's try this again. There we go. Now our zombie just sort of stands there and everybody just walks past them because like, what's this? We don't care about that. But now we're gonna turn this on and we're gonna see zombies move towards groups of humans. All right, so, oh, that's not good. Are you in existence, but like way off to the side? I'm a little bit worried about that. Dota, hello, Bugs Bags Bigs right here. Now I think when we add our zombie, we have our zombie speed. I think you might be way too fast. Let's try like 001, like very, very slow. Because I'm thinking that what's happening is it's like teleporting off the screen. You're gonna finish your current thing early? That sounds good, I think. You have an approve reject kind of gate, but the reject flow isn't defined at all. That's not super nice. I did define a custom 2D vector. I didn't need to. We could have just used vector 2 from like an algebra. Probably would have been better and easier. Let's see. So what's going on here? Somewhere in here it is. I do not use Rust professionally. No, I don't. I just do it here. I play a Rust developer on Twitch. I use mostly like web development stuff at work. So professionally, I'm a technical team lead of a web services team. So yeah, very few companies are using Rust professionally right now, but they seem to be using Rust very effectively, the ones who are. But it's still definitely like across the chasm thing that needs to happen. So here it is, the zombie attraction. I'm worried that this is like just way too much. So instead of doing this part, let's just debug what this would be. So like, what is this force that we're asking to be added to the zombie acceleration? Oh, wait. Did you see that? I see some nans. I see some nans. That is not gonna, that's gonna cause problems. Yes, there are some huge companies using it yet. Using it right now. But I think like when you start seeing essentially like small companies, like a lot of companies, and like recruiters are starting to like add it into their vocabulary, then I think that's when like it's gonna be easier to get a job as it. Right now, it's still one of those things where like, okay, we want the smartest people that we can get. Let's just use Rust because that will attract the smartest people at type thing. Yeah, like learning things for our careers like is important. Small to mid-sized, yeah, but I think like the natural way for that to happen is startups become small and mid-sized, and they've been using it the entire time. It is kind of hard to like convince a company to completely change a stack unless they're starting a new project. In which case, then it's usually a little bit easier to add in a Rust stuff there. Okay, so what could cause this to be nan? So if it's nan, so we could have a normalized problem. I think it's a normalized problem. I think we're having like a divide by 0 issue. That could cause a problem if it's divide by 0 or divide by like too small of a number. So let's see, if I don't have that, do we ever get nan? Oh, look, yeah, there's some zeros here. There's some zeros. Two languages you definitely want to work with in the future are Rust and Go. Well, Go is like very popular in the cloud list, so I would like Go is a great language to learn right now. Yeah, like Amazon leans heavily into Go, and you can do all sorts of like cloud stuff with Go and all sorts of DevOps things with it. I think that would be a great language to learn if you want to go into like DevOps. Okay, so we need to verify. Okay, so when we get the magnitude, no, when we normalize, we can't just blindly do this. We have to check to see. Okay, so we get the magnitude. If the magnitude is 0, I think that's a thing. Then I don't want to return it by 0. Do I just return? I don't remember what you're supposed to do with when that happens. Just set everything to zeros. self.x equal to 0. Otherwise, do all this stuff. Zero is not a thing, is it? Oh, there's no 0 in F32s. That's why. So if magnitude is equal to 0, that's 0. We can try this, and then we'll put you back. We'll add you back in. We can still debug you, just like the double check. Yeah, you want to go for DevOps? Yeah, DevOps is a great field. I still like prefer normal teams to like do all the DevOps themselves and not have like a specific DevOps team. Because like if you have like DevOps teams and they're separate, then you don't have DevOps, you have ops that can do dev. Which is there's a subtle difference there. Look at this. We're moving around. Okay. I wonder if it's because like sometimes I can't find other human locations. No. If like the human location distance, It's less of like the devs. So like super what is it the right word? What's the right word for it? It's a I'm gonna get into like sort of like it's a syntactic sort of like difference, like a little nitpicky. It's not the devs that own DevOps, but it's the team that owns the DevOps for the product that they're working on. Does that make sense? So like if a dev on a team needs to have an EC2 instance, let's say on AWS, to like play around with it, then they should have the power to do that themselves and not request it from a DevOps team. Now, that might mean that there's a DevOps person embedded with that team that they can pair with and then get that going. But at least it shouldn't have to leave the team. That's usually what like I see in like the really successful companies who are using like DevOps properly. It's going to be a major field. Absolutely. It already is. It's because like you can't really move fast without automating all of this stuff away. Okay, so we're moving really slowly now, which means that we can come back to our add zombie and like maybe go back to this again. And did we remove our debug? We did. Okay. So now we should run this again and it should be a little bit faster. I feel like I did it backwards again. You're avoiding the humans. And a zombie that avoids humans is safe, but not exactly that fun. So what I want to do is say human location minus the zombie location that get. Okay, so yes, this works really well. I foresee a problem. Our humans are gonna get murdered really fast. This zombie is not like your old school's Romero zombie of the 60s that just slowly shambles forward. This zombie runs. This is not. This is too much. Everybody will be dead within like minutes, seconds. Let's slow you down again. Let's try like 10 times slower. The card game, I still need to like deploy it. I just like, I've been not doing that. I just been procrastinating by doing other stuff. Okay. If there's enough people near the zombie, ironically, the zombie is relatively safe because he tries to go towards everybody. But if there's only a couple people that can see, he's gonna get them. So this is good. Zombie sort of like now moving towards humans that can see. And it's like zombie-like in the fact that it's not very good at moving. But it does tend to cross over people pretty quickly. So I think this will work. Okay, so if we have that, that's fine. Zombies are attracted to each other, attracted to humans. Let's clean up our. Yeah, so we're not using you. I guess we can just clean up all of you. So zombies are attracted to humans. All the humans that they can see. I didn't make any changes to BBECS. All right, so what would be next? Next would be, I kind of want now humans to run away from Zambons. I saw Kanban there, and I'm like, humans run away from Zombons. Zambonis. Dota, do I use Kanban or Scrum? So, personally, for like just my personal to-do, I tend to use more Kanban. For my team at work, I'd say like a bunch of Scrum, but also a bunch of Kanban together. So I've heard it. I didn't invent this, but I've heard it. I've heard it called Scrumban. So that's what I'm doing. I'm doing Scrumban, which is a combination of Kanban and Scrum. And it seems to work pretty well with us. I don't have a source for that. I'd be happy to go over like how we do stuff. It's like the stuff with Scrum. Pretty much everything that I do with Scrum is actually to keep to organize efforts with the rest of the business. Because what I've noticed is when it comes time to like figuring out like what the business wants, they're really big like on like, okay, I want the dev team to commit to doing all this work and all that stuff. So then I need is like, okay, well, I now need you as a business to commit to at least for the next 2 weeks that you want this thing. Because if you can't commit to that, I don't want to do it. Because if you're just going to change your mind halfway through, why should we even start? So like it's like halfway, like we meet together and like we both commit. And by both I mean like the team and the business. You realize when you do your feature flag presentation, you have to dive into trunk-based dev more. Yes, I do. I've been moving my team to trunk-based dev just slowly over time. It's really nice. Like the non-trunk-based dev, it's just like there's so many little problems that shouldn't be problems that crop up because of it. and they don't feel like you should have them, but just they eventually come up. You're doing PRs. Well, like if the PRs last a while, then that's the problem, right? And you eventually realize all my PRs have 1 to 2 commits. Yeah, at that point, it's like, well, why do you can still do PRs. So I still actually like the idea of PRs with trunk-based development, but that's because it's really easy to see the PRs in the history, in the Git history, and then you can like squash and merge those PRs in. So then, I don't know, like it's probably not using PRs exactly what they're supposed to be doing for. With trunk, it's extremely helpful to do very, very small commits very often. Absolutely, yes. That's very true. Okay, so what are we doing here? What are we thinking about? We now want humans to run away from zombies. Which is why you're supposed to have pairing mobbing for trunk. Yeah, that's another thing too. Although I've heard some people in the agile community who do trunk-based development, they don't always agree with that. So so here's the general idea. To keep quality high, you need one of two things. You need you need multiple eyes on the code that's being added into the code base, right? So that's usually done in the form of a review, like a code review that happens after the code has been done. Something that changed my mind on code reviews was, can't remember who it was, but like somebody stated, well, in the code review time, if there's a problem there, you can't add quality in at a code review. All you can do is gate and like stop something from moving forward. So if you want to have the highest quality possible, then that code review needs to happen during development, which is pairing. Because you can't QA quality into a product. You can just gate. I think that was the quote. You can't QA quality into a product. And if you pair mob, then it's automatically reviewed at that time. If it's not reviewed at that time, then you're not doing pairing right, because that means that you're not like paying attention and it's not working correctly. Yeah, so like, it was a huge thing for me because up until then I was like, well, there's still value in code reviews. And then I found out that like almost all code reviews, and including the ones I were doing, are things that automated processes should be taken care of anyways. Like I'm looking for style things, I'm looking for other stuff, big architecture stuff. There's a huge amount of pressure to not throw that back for that, because that's like essentially rewriting the entire ticket, and that's going to take a lot of extra time, and that was a lot of extra wasted work. Like that needed to be essentially chosen and figured out at the beginning of the ticket, and not like basically say, okay, well, everything you did, just go away and do this again. There's now pressure like, oh, I kind of want to kick this back, but I also don't want you to take 3 more days to do this. Exactly. The architecture stuff is solved by having an architect during the writing of the code, at least during the beginning of it. Yeah, so what I've learned from Nigel Thurlow, who worked at Toyota, so basically what I learned from Toyota is that you can have the best of both worlds. You can have pairing and not pairing on the same team. And the way you do that is something called an and-on court. And so if you have a culture of a team where you're really willing to like just like stop all development and like pull everyone out of flow in order to like make sure that everyone can be in flow. I know sounds a bit weird. All of this stuff is really complicated, unfortunately. There's no like really simple answer for this. Then basically this is what it looks like. Okay, I'm programming this thing. Oh crap, I'm recognizing that like I have a decision to make and I'm not really sure how to make this decision. Instead of making an assumption moving forward, I'm gonna pull the and-on chord. This comes from Japan and Toyota. Everyone stops what they're doing and we all swarm on the problem, and then we fix the problem, we all learn together, and then we can go back to what we were doing initially. That drops us all out of individual flow, but allows this the system flow to stay high. Why not just ask your team lead only? So the reason why, so it's a good question. It's a super good question. If you want to maximize individual flow, you would do that. Just ask the team lead only, and that way one person is being knocked out of flow and everybody else stays in it. But what Toyota realized a long time ago was then only two people learn, right? The team lead and the person asking for help. But what you want is like the entire team to learn and like have the most context like all the time for what's going on and like how we do architecture and how we solve things. So by pulling the and-on chord, having everyone stop to go in, everyone gets synced up multiple times a day. And therefore, you don't need to, it just makes it a little bit easier to like make sure that everybody knows what's going on for all the product, all the tickets. We were in an escape room and the CFO said to me that he knew with 10 people in the escape room, so much information would be lost into thin air. And he knew that from working at a company of 300 people. I think of something similar with just running it by the team lead. Yeah, so that's the big thing is like, what are you optimizing for? Are you optimizing for individual flow or system flow? I'm experimenting with optimizing for system flow, and that does mean that individually we get knocked out of flow more often, but as a system, we get more done faster with higher quality. Super awesome. Dota, that just reminded me of a really amazing infographic that I want to find. Actually, you know what? I can just show it to you here. Because it's like easy to recreate this. So I hadn't really thought of like the cost of like the number of people in the cost of the number of people in like a team, but it's pretty easy to visualize once we get to this point. It sounds super hostile to remote workers. So this is where remote first has to come in, right? If this is like a hybrid team where we're like in the office and like they're pairing partially, like there's in office and then remote from office, then yeah, I think it can be super hostile to remote workers. Our team, however, we decided to be a 100% remote team. So we're making it work fully remote. What it does mean is that we jump onto, we're using Teams for this. We jump onto like Teams meeting constantly throughout the day, and then off again. But that's not really any different than like somebody coming in and just like, hey, can you join us over here at the whiteboard? We need to like look at something really quickly. It's basically, we're trying to imagine it like this. And we're using tools like this, freehand, as like a, just basically giant company whiteboard. Okay, so imagine we have a team of 3 people. The communication layers, so for any one person to be aware of everybody else, is like that. That's super hostile. I'm in a 4-hour different. Oh, okay. So I guess like there's different things. I don't have any team members, so we're all remote, but we're all in very similar time zones. I don't know how this would work for a team in like vastly different time zones. You're right. That would be hostile to different time zones teams. I don't know how to do that. I don't know how to do this properly for, yeah. But yeah, it's I think for me, everything I'm talking about right now is like the teams can't like have overlapping time zones, and overlapping work hours. We'd have to figure out something very different for like a different time zone situation. Basically, what I think it would be you're not on the same team as somebody who is on like 12 hours away. That would be someone else outside. But I haven't run into that yet, so I can't like I don't have any good answers for it. Okay, so a team of 3 people, for everyone to have good communication with everybody else, there's only these 3 lines. Now, if we add in 4 people, now for everyone to communicate with everyone else, we have what? 1, 2, 3, 4, 5, 6 lines. And then we're gonna move on to, what is it? 5 people? 1, 2, 3, 4, 5. So we do this. And do this. You could probably see where this is going, right? So that's 6 people, then 2, 3, 4, 5, 6, 7. It gets really pretty. It's a fractal. So we have that, then you. Yeah, it gets to the point where like you can't even see it easily anymore, which is kind of sucky. But like as you can see it, so this is 7 people, and it's already really hard to see the lines between them. So when you're talking about having a team of 10 people, just imagine how many personal connections you have to maintain, like lines of communication have to be maintained to be able to like get information from any one person in the team. I was looking at it and thinking, oh man, this explains why large teams are exhausting to just be in. It's just exhausting to be on a larger team, because you have to constantly maintain this communication. It's also, now my team at work is this. I'm on a team of 3, me and 2 other people. Super, super easy. So like when I'm talking about like, oh, we do all these pairing, we all this stuff, like this is why it works, because I'm on a very, very small team. I would say I'd be willing to go up to this at most, not willing to go up to the next one. It is amazing how fast it just explodes. It's scary actually. Yes. Now this also gets into like if you do need like multiple people to be working on the same thing, then there's this theory of multi-team systems, in which you'd say, well, instead of creating this, what if we have 2 of these? That would be 2. What if we have 2 of these, and so we have this system twice, and then we're going to hire 1 extra person, and then the team itself has this line in it. And so that's a I don't know if like what that role specifically is, but it's like an inner team, like connector. Like their job is to like ensure that the teams are actually like working on the right things, that they're not duplicating work. It's not exactly a product owner, but like a product owner can work on it. It's not really a product manager, but like there's a lot of things that go inside of it. Basically, they're making sure that it's like cross between like a team lead, because like each team has their own lead, right? Like you would say that maybe this is like the lead. So we have the lead, and this is like somebody outside of the teams who is helping make sure that they're all working together properly. It's a bound. So I think like the book that I was reading calls this the boundary spanner. And that's it. And they would often work with the team leads. So like oftentimes, let's see, it wouldn't actually look like that. It would look more like this. They would work with the team leads to make sure that things are working fine. Now you can imagine that with enough of these, you run into the same problem again, but you've delayed it. You've given yourself time to like have more people, but not have the same problems. The other issue of this is like you quickly run into a situation where you just have no idea who else works at the company, because like there's just too many people, too many teams to like really figure that out. But yeah, this is basically the more number of people you have, the more people you just need just to coordinate humans. It's crazy. Like we usually think like, oh, we don't need to like hire somebody just to be like, just to figure out, like just to keep people, you know, understanding what we're building and what other people are building. But no, you do. You need to hire people just to coordinate. And these aren't managers. These wouldn't be managers. These would be coordinators, essentially. Communication people. And that would be it. All right, let's see. For this, we want our people to... Humans should now move away. So, oh, this is gonna be a different system. So we have human repulsion from each other. So we have human repulsion from each other. Well, okay, have a good shower. Do I want human repulsion from... Do I want to do this here, or like repulsion from like zombies? Like run from zombies, essentially. I don't know. Also, I'm thinking of in main increasing our human vision range to like maybe 50. And in human repulsion, are you looking for just other humans? You are only looking for other humans. That's what it is. Human repulsion. Okay. Now if I increase that, what does that make this look like? Okay, so they're trying to stay away from each other, which is good. So we're gonna want to create another system here for like run away from zombies or something like that. Run away from zombies. Print line, I am running away from zombies. Well, thank you so much, Rust, a co-pilot, but that's not... I want them to do more than just yell out. Like, what do you want? What are you trying to do? Literally, just yell, just scream, and then do nothing. Also, I like this one, the last one. I'm a zombie. I'm running away. That's cool. We're just gonna return okay. And close that up. And then close you up. Okay, so let's set this going. So this is in our main library. Yeah, let run away from zombies. Okay. I think... Will that work? No, not really. You don't know how to find it yet properly. And then we'll run away from zombies. Run. Oh, that works though. Oh, you know what? I screwed that up. Yes, we're supposed to have a world in here. There, that makes that happy. So nothing is happening right now, but how is this gonna work? Okay, so for run away from zombies, we're gonna have our humans are going to, so for every human, let's see, for every human, like, let's see, find the zombies that they can see and move away from them. That's pretty much what it is. And move away from them, like just get the average location of where they are and move in the opposite direction of that. That's what we want. Now, I don't think Copilot will yeah, because like we don't have like humans. We have to query for that. We have to do all that other stuff. And I think we're gonna get to this next time. So what I'm gonna do is, let's see, you are still dead, right? If they're oppositionally equidistant, would you stay still? Yeah, I think they would. But that kind of makes sense, right? Like if you have a zombie to the left of you and you have a zombie to the right of you, you're like, where do I go? Where do I go? I don't know where to go. I'll just stay here and hope that they don't kill me. And then they'll come and kill you anyways. So yeah, something like that. Also, hello, yay. Awesome to have you here. Let's see. Of course, I'm about to end too. So you're still up. I should be able to, let's see, can I do this now? Oh yes, I can now. Okay. So I got a new Stream Deck. And I set that up last night, but I forgot to like actually add any of the things into it. So I need to like reset, like re-add that. I was using my my phone before to do that. So let's see. The final thing would be I want to find out who is. Yay! Are you Because you streamed for a while. Are you planning on streaming again? It was always like interesting to watch you working on like on air or any of the other like crates that you have. You would like to? Oh, that'd be awesome. Yeah, if you stream, then Oh, you're not. Yeah. Okay. Hold on. I'm getting confused with all the yas. Okay. Oh, okay. You're not. Yeah. You're yay. Got it. Okay. I've too many YAs then. Sorry about that. All right. So let's go ahead up and set a raid. We can raid. Let's see. Mr. Halsey is the smallest Rust developer streaming right now. I know, I love Air. It's a great crate. Plus also like all of the other yeah. I need to figure out how to pronounce it so it's different than yay. So ya is makes like all sorts of great pun related crates. It's awesome. Okay, so let's go ahead and start a raid for Mr. Halsey. Should also like go over there. So I can join you on chat. Mr. Halsey does a lot of Rust dev, but he's also been working on something called Mimeograph, which is a replacement for what is it? WordPress. Like it's a cloud-based WordPress in Rust, which is sounding pretty awesome. So with that, I hope you have a great rest of your days, and I'll see you all next time. Bye.
And what does that mean? We're working on something called Mimeograph.